Find the difference. You are given two strings S and T. String T is generated by random shuffling string S, and then add one more letter to a random position, return the letter that was added to T. So when we look at this example, S is A, B, C, D, and then T is A, B, C, D, E, right? So E is the new added to the T after the characters from the S, right? So the new added characters can be anywhere they want, it's randomly, and then we don't know where they were at, we don't know which characters they were at, right? So this case, A, B, C, D, and then A, B, C, D, E, right? So what about A, and then so what about this case? So E is the new edit. This is really obvious, right? What about A and then A? No, A. Other time, A is the new edit, right? Okay, so what we will look at this example, and the way I'm gonna do, the fast way is I will use the data structure. It's called dictionary to save my keys and value pair. The key is gonna be the characters we will point, and the every characters, the key is the characters, and then the value is gonna be the counts, how many counts in this string. Okay, so dictionary one, in the D1 it will have like A is gonna be 1, right? Because A is 2 because we found A 2, and then B, and then C, and then D, right? B is just 1 time, C is just 1 time, and also D is also just 1 time. Okay, so what about dictionary 2? In the dictionary 2 we found A is 2 times, and then B is 2 times, B is just 1 time, and then C is also 1 time. The same way, D is the 1 time, but E is the 1 time. Okay, so because the strings T will always greater length, right? We have the greater length than S, because T is the one which is added, right? So if S length is 5, T length will be 6, right? So we will look every characters, every values in the dictionary too, because this one has more items, right? And then we will check, hey, A the same, yeah, they're the same. Okay, so we cannot say okay, only E, there is no key in this dictionary one, so we will return E. Okay, so what if A at the time, this one's gonna be 3, right? So okay, if their count are not the same, okay, we will return A, right? Okay, let's do that way first. Okay, to use that way we need some data structure to save our key values pairs, right? So the data structures we use is dictionary, and then dictionary one for the string S, and then second one is for the T, and then we will compare. Okay, so let's see here. On our dictionary, and I will save as a key character, and then integer as a count. D1. Okay, new DICTION in our dictionary, characters, and then integer. Okay, and then for every character in S, I will add it to my dictionary, right? If D1 dot, we need to check that one, right? Contains key. If they are the key, we will just add the values, right? So D1, the key is C plus plus. That means D1.C is gonna be like from 1 to 2, 2 to 3, right? If there is no key that like that, D1.add, we will add key as character, and then the count's gonna be the values. Okay, so by doing this way, we will do for the T. This one's gonna be dictionary 2. We will check in dictionary 2, 2, 2. Okay, so we will loop again for each, which one we're gonna loop. We will loop in the second dictionary, right? So we will have key value pair, key value PIR, right? PIR pair, characters, comma, integer, and then key value pair, P. I will just put as P and then int D2, right? In the D2, right? Okay, and then we will just check if D1, right? We will just check this P key, right? So D1 dot contains key P dot key. If the key is not contained, that means like the E case, at the time we will return P dot key, right? Because we just save the key values, right? And then the next case is the count, right? D1 dot P dot key, right? KE1 key not equal D2 P dot key. That means this case, right? A is 2, A is 3 at the time. D1 dot P, D1 at the P dot key, like A is 3 and then A is 2, and then this one, this case, at the time we will return P dot key. If D2, right? If D2 contain, no, D1, I'm sorry. Yeah, it's true. It's D1. We'll check this one. If in D1 there is no key like E, we will return this one, and also or, right? Either case. Okay. So, find the difference, not all codes. Okay, so we need to return something, right? Return, okay, I always just return one, A or B, or anything we want. Oh, cannot return like this. Okay, I think we will not reach this condition at all, right? So then we can return anything we want. Okay, so this one is this one is we just use the dictionary data structure with, right? So the memory is gonna be big, right? This one is if it is the numbers of characters in S is N and the numbers of characters in T is M. So aura of N, right? Aura of M. So the time complexity is gonna like bit log aura of N, right? So it's good though. But instead of doing like this like many lines of code, we can use XOR. XOR, like this symbol. That one is in our when we get the characters, we can get the integer values, right? Like the ASCII code, and then we can remove all the duplicates. For example, if we have A, B, B, C. At the time, if we want C, we can use XOR, because XOR is if only one of the item is true, we will get true. I mean, only if they are different, XOR will give us true, right? I mean, for example, 0, 0, that means false, false. Other time, XOR is gonna give us false. What about 0, 1? What about 1, 0, right? For example, we have many cases, right, in our binary. Okay, 0 and 1. Okay, at the time, 2, true, false. So when we think about this XOR operations, we can say, oh, if two items or two values are the same, if they are the same, we got false. Only if they are different, we got true. So when we look at this one, A and A will give us true, right? And then A and B, and then A and A, and then we have to keep doing that. At the time, they are the same, right? And then the last we can get is this one, only this one. So when we can calculate that one by converting the characters to ASCII code, and then we can use that one. So for instance, A cap XOR XOR XOR, and then C. At the time they will give us some integer value, the numbers like an integer, like number. So when we change that code to character, we will get that C. Okay, so and then we can try manually, like one by one. I don't want to go that long, and then I will just solve this problem by using the XOR. Okay, so sorry. Okay, let's try this one, right? At least it is better to try. Okay, so I will have the result. The initial value is gonna be just 0, right? Because we will start at 0, and then for each every characters in X, and then we will XOR, because currently we have to XOR everything, right? Only at the time we will get this A, right? Not the one who is not duplicate. Okay, if it is E, we will get E. If it is A, we will get A, because they will remove only the duplicates, not characters like duplicates. For instance, if it is A, E, E at the time, no, it will remove every the same count, right? So okay, let's do this by XOR, right? What is my cat? But yeah, XOR, and then characters. We need to change the characters to our, what is it, integer values, right? And then we will get the code, and then we will XOR. The same way for T, and then when we get result, we will get XOR, we will change that code to characters. It is a trick, right? It is a very useful trick of the XOR. When we see the, for example, not only these problems, when we look at this one. So for example, I think it will have, okay, I'm gonna go, for example, they will give us one array, like one strings, A, B, B, C, C, D, T, F. Okay, for example, like F or something, they will say, okay, every characters will be duplicates, or will have the same count in this string. Only one characters will be only one time. So at the time, AA, the count of A is gonna be the same, right? 2 or 3, they will be duplicates. 2, whatever it is, right? So at the time, if they are duplicate, we can remove all the duplicates, right? And then we will get only the one which is left. Okay, so that's it. Thank you. Oh, I'm gonna submit this one. Let's see what will happen. So when I try this one, okay, cool. I'm gonna submit this one too. Let's try if it is working or not. I just checked many. I didn't check this big case. Okay, I'm gonna try this one to make it have a check. Okay, it's working. I'm gonna submit this one too. Okay, so that's it. Thank you.